Yes, it is. Yeah. If we go through these one by one, you're just going to get, your questions could look different than this, but they're all going to be kind of the same format, right? Now, on the practice test, I did some new stuff that I think will be really helpful to you on this practice test. It's not worth anything. I'm not going to require you to do it, but I do this every year, and in my experience, the people that do these things, it helps huge. I mean, if you do the practice test, you could literally know what you're going to get on the test before you walk in if you do this a few times, right? So first question, they want us to write the domain of this function using interval notation. So what is that going to look like? But interval notation, that's not an inequality, right? That's where I just use the comma separating the left and right endpoints. So what am I going to put where? What number goes first? -9, right? I have to go from left to right. It's like a number line, from small numbers to big numbers. So -9 is going to be my lower limit. Whoops. What's my upper limit? Hannah, what's my upper limit of x on this one? -6. Good. Now all I have to do, those are the right numbers. Now I just have to know what kinds of enclosures do I put there. Do I put rounded or square? Square in both cases. How come? Because I'm including the endpoints. Good. So that's all I put, right? That's right. Okay. Next one is a range question. Okay, so now, and you got to make sure you read these things carefully. You got to get out of Moodle practice mode, which I intentionally, I set it up so you can, without penalty, try things, right? I don't want you to be scared to put an answer in when you're practicing. But when you're taking a test, every time you put something in, it is going to get deducted. It doesn't matter if you get the wrong answer first, but you get the right answer second, you could get half credit, right? If you miss it once, I'll take half off and let you try again for partial credit. But after you've missed it twice, you can't get any credit on the test on that problem, right? So you can't just try stuff. You got to be very careful before you hit check. So what about this one? If I'm using interval notation, and this time I'm trying to find the range. What's the range a measure of? Y values, right? Those are the output values or the Y values that are graphed. So same kind of a deal. We're using interval notation, right? So I'm going to put a comma between the left boundary and the right boundary. And when I say left and right for range, what I really mean is like bottom and top, right? So what is the bottom boundary, or is there one? Negative infinity. There isn't, right? This function goes down forever. So at the bottom, there's no restriction. It's unlimited, right? What about the top? Is there a top value of this function, a biggest value of y? -3. Okay.
But if you switch them around, it'd be wrong?
It would be wrong. Yeah, because what that would say, if you switched them around, that would be like saying y is greater than -3 and less than negative infinity, which doesn't make any sense, right? It has to be like a number line. Think about a number line. A number line goes from small values to big values, left to right. So it's got to match the direction of the number line, okay? Next issue is what kind of enclosures do I put on that? So I'm going to put a rounded bracket on the left, right? Because I can't include that endpoint. What about the right? It's going to be square, isn't it? Right? Because the ant actually can stand at a y value of -3. So it'd have to look like that. So once again, how do we put that in? So in Moodle, to put that in, all you have to do is I'm going to type on my keyboard, I'm just going to type Shift-9, which opens up a set of parentheses. And then I'll go -infinity, comma, -3, but then I'm just going to type a right bracket, which is the one that's to the right of the P, up here kind of on the upper right of the keyboard, and it just replaces the rounded bracket with a square bracket. Okay, let me get it wrong for a second. Let's say I put in -4. I'll show you what happens. So if I get it wrong, it says try again for partial credit. Okay, so if I want to try again for partial credit on a test, I would have to hit try again and go back and fix any issue that I had, right? So I'll make that a -3, and now if I hit check, I would get half credit, 0.5 out of 1. Make sense? Okay, on these things, there's also, I think this is really a cool feature. I got this set up so when you're doing a practice test like this, you can redo a question if you want to. So if you want to get some additional, say, okay, I got it, but I'm just not sure, give me another one like that. Hit redo, and it'll pull up another question that you can do for additional practice. Okay? Questions on that? Does that make sense? You won't get that option on the test, obviously, but. Okay, what about this? Endpoint stuff, or end behavior. So, enter an answer that correctly fills in the blank. As x approaches negative infinity, right? So what does that mean on the graph? Where's the ant walking? Good, so that way, how far? Forever. So as he walks that way forever, what is his y value doing? Approaching what y value? Positive 2, right? Okay. So that's the answer in this case, is 2. What if the function did, let's say it did this instead. Say it went down and it did that instead. What would my answer have been? Negative infinity, right? Because now as he goes to the left, he's going down forever. See what I'm saying? Okay. Questions? Okay. Okay. These, I can see why these, I mean, this takes a little bit of thought, but we're getting to the point where I feel like people are able to do this. And if you're not, you need to get some questions answered, and this is something I'm going to expect you to be able to do. So we want to be able to write intervals. This question is going to be increasing or decreasing. In this case, it's decreasing, but it might as easily have been increasing, right? We want to find all the intervals on which the function is decreasing. So you got to interpret that, first of all. Read the directions carefully. So as an ant is walking in the positive direction, what does it mean to him? What is the shape of the curve going to be if it's decreasing, if the function's decreasing? It's going down, isn't it? That just means downhill. So we got to find, now am I looking for x or y values here? X. The only time I'm looking for y values would be if it's asking for what? The range. Yeah, exactly, the range. Or I guess when you're doing end behavior, you're asking about a specific y value, right? But otherwise, we're always, when we want to know an interval where something's happening or where something's happening, it's always x values, input values, right? So what's the input value, the x value, where the ant, when he's walking in the positive x direction, so from left to right along this function, right, he's walking along this thing, where does he start to walk downhill at x equals 0, right? So that's going to be the left edge of that interval, right? Where does he stop walking downhill?
Negative.
It looks like
4.
positive 4. I'm looking for an x value, right? So if I write this as an inequality, then how am I going to write that? X is what? Greater than 0 and less than 4. Do I include equal signs?
Yes.
I don't.
No.
I don't include equal signs because at 0, the function is actually flat, right? I could balance, if I really was careful, I could balance a ball on the top of that mountain and it wouldn't roll, right? But if I push it to the right at all, it's going to roll down. Make sense? And same thing down here. When he's standing at the very bottom, it's flat. So it's only between those two, between the peak and the valley, the maximum and the minimum, that it's actually going downhill. So that's my answer. Okay? Okay, you're going to get another question. This time it's going to ask about where the function's positive or negative. In this case, it wants to know where it's negative. Now, once again, you got to interpret that, right? We said decreasing meant the ant is walking downhill from left to right, right? So the slope is negative. Increasing would have been walking uphill, right? What about positive, negative? What does it mean if we want to know where the function is negative, right? When the function's negative valued or negative. Where is that going to be on the graph? What's it going to be? Below the x-axis, because we want to know function just means the y value, right? So where is y negative? Below the x-axis. So where's that going to be? Well, these are going to be the endpoints right there and right there, right? Does that make sense? So then I just want the x values between those. So what's that going to look like? Well, x is what? You want it as an inequality, right? So how am I gonna write that?
Greater than
Greater than -7 and less than 1, right? Okay, let's change the question for a second. Let's say instead of asking where it's negative, let's say we asked where it's positive. That would be different, right? That's where it's above the x-axis. And so that would have been up there or up there, right? So how would I enter that answer? There's two places. Oh, and by the way, would I include -7 and 1, and 1? Should those be included? I want to know where the function's negative. Is the function negative when it's on the x-axis? No, it's 0, right? That's not negative. Okay, so that's the correct answer for the first part. What about for the second part? If I want to know where it's positive, how would I say this interval right here? X is what? What x values would have the ant be above the x-axis when x is what? Yeah, less than -7, right? It's going to be all the values when the ant's walking from left to right. It's before he gets to -7 that he's above the x-axis. So left of -7, which means less than -7, right? Comma, we got to separate because there's two intervals. We got to separate them with a comma. What about the other one? How would I say this interval? X is what? Greater than 1. Okay, so that would be, if we were looking for positive, that would be our answer. Okay. Oops. Okay, so this time we're looking for an average rate of change. So average rate of change, this is a really easy one too, because all we're looking for is just the slope between the points. That's it. Average rate of change only depends on the endpoints of the function. So by endpoints, I mean the values where we're calculating the rate. So we're starting at 0 and ending at 2. All we care about are those 2 points then. Well, where is the function when x equals 0? Well, it's right there. It's on y equals 0 too. But if I go over to x equals 2, the function has a value clear up there, right? So the average rate of change is just the slope of the segment connecting those two. That's it. So all I've got to do then is just rise by a positive amount because I'm going up. So I'm rising by +7, and I'm running by +2, right? So the rate just equals rise over run, so that's going to be 7/2. Can I reduce that? I can't, right? There's no number that goes into 7 and 2. Do I want to write it as a mixed number? No way. No mixed numbers. That's middle school stuff, right? No mixed numbers. We just write it like that. Okay. What if it had been 2/2? How would I simplify that?
1.
1. Okay. Make sense? That's it for that one. Okay, so all we're doing here then, a couple questions that have to do with transformations, translations, stretches, things like that, reflections. So what are we doing here? We want to know if this is our parent graph, we want to select which one of these choices corresponds to this transformation. So all we've got to do on this is just take this transformation and interpret it in terms of, moving left and right, up, down, that kind of stuff, right? So if we're going to compare g of x to f of x, and remember, all we have to do is multiply a times f of x minus h plus k. The values of a, h, and k will do all the things we need it to do, right? I won't put any b's in there. Okay, I won't put any horizontal stretches or compressions. So what does a do? Real quick, what does a do? If I multiply a function by a, what's it do? Right. It stretches or compresses it vertically, right? Do we have an a here? No, we don't even have that one. We can forget about that one for this problem. So no a's. But I do have numbers that are being subtracted from x and then added or subtracted to the whole thing. What does h do? Horizontal translation, right? and K is a vertical translation. The only part that's at all tricky on this is that, remember, how far is it being shifted? What is the value of H here in this function? It's 7, isn't it? So H equals 7. And so that means we're shifting it which way? To the right. We're going to go to the right by 7. But if you look at that function, that's a little tricky when you look at it. Because that's a minus sign, that's the one where people sometimes want to make that go left instead of right. Remember, when you're shifting horizontally, you're going to go in the direction that is going to be opposite of whatever the operation is there. If you're subtracting, you're actually going right, because that makes H positive, right? If that's a plus sign, it means you're actually going left, right? Okay, so then this means we're going to the right by 7. What does the minus 6 at the end mean? What's that give you for a value of K? Yeah, negative 6, which means we're going down by 6, right? So we just have to find that one, and that's it. Only one of them will work. So which one goes right by 7 and down by 6? Looks like maybe this one, right? There's the vertex is scooting right by 7 and going down by 6, so that's it. Okay? Okay, we got it. Okay, this time you have to interpret what these values mean. So what's this mean if we're vertically stretching by a factor of 2? Which parameter is that? That's A, isn't it? That's telling us A equals 2. If we're translating right by 6, what's that telling us? What's the parameter that controls horizontal translations? H. And so that's telling us H equals 6, because we're going in the positive direction, right? What does it mean if we're translating up by 3? Which parameter is that? K. Good. So K equals, up is positive, right? So K equals 3. And we're just plugging in answers for, we're filling in the blank here for A times f of x minus h plus k, right? So we're going to plug in positive 2 times f of x minus 2. What if, 6, sorry, not 2. Right, h is 6. What if h had been negative? What would happen there when I subtract it from x? Right, I end up with h minus a negative. Subtracting a negative is just adding, right? So that would have made that a plus sign, okay? And then last one, k is 3, so plus 3 for k. And that's what you're inputting, okay? Questions? Okay. Let's see. And then 2 of them have to do with inverses. So what do you do with something like this? If you're given this function, I'll make it a little bigger. If you're given that function, how do you find the inverse? Just follow the steps, right? The 4 steps. What's the first step?
Switch x and y.
Well, okay, first we're going to write it in terms of y. So we'll make the f of x a y. So we get y equals 7/3 x plus 3. Now, second one is I'd switch x and y, right? So this becomes an x, that becomes a y, and now this is probably the bigger step. What do I do next? Solve for the new y, and that's my answer, right? So I've got to isolate y. Okay, so what's the first thing I have to do? Austin, what's the first thing I have to do if I want to get that y by itself? Subtract 3 from both sides. Very good. So those cancel. I get x minus 3 equals 7/3 y. Okay, what about this one? What am I going to do here? How do I undo multiplying by a fraction? Riley, what do I do here? How do I get rid of that 7/3?
Switch to 7/3.
Good. So I'm going to multiply by the reciprocal, both sides. Good. So we'll multiply both sides by 3/7, right, to cancel that. Why is this wrong, though? If I enter that, I'm going to get it wrong. What did I forget to do?
Parentheses.
Parentheses. What this says is 3/7 times x only, then minus 3. But when I multiply, remember how we say this? We're multiplying both sides of the equation by 3/7. So that means I've got to multiply the whole left side, got to put it in parentheses, by 3/7. The question does not ask you to simplify this, so you don't have to distribute. You can if you want to, but to me that's, in a way, you're just adding more complexity. You might make a mistake. If you know you can do it right, go ahead, but I'm not asking you to. That would be fine. If you just input 3/7 times x minus 3, I'm good with that. I just want you to know how to get the inverse. Okay? Questions? Good. Then last one is, I think, a pretty simple one. Okay, on this one we want to know in which graph are the blue and red relations inverses. So the question all you have to know here is, what is the graph relationship between a function and its inverse, or a relation and its inverse? What kind of symmetry do they have? They're going to have what? See, we have, each one of these shows you some different kind of symmetry, or a translation, or something's going on, but we want to know which one shows us the right symmetry. What is the right symmetry? A function and its inverse would overlap if they're reflected over what line?
Y.
No, it's not y, the axis, and it's not the x-axis. Remember this, it's been a while since we talked about this, but it's this line right here. That's the axis of symmetry for inverses. Okay, and that's all that is just the line y equals x. So in this case, that's actually the one that works, isn't it? First one. Everybody see that the blue and the red, if I fold the graph on that green line, they overlap perfectly? That's it. That's all we're looking for. That's the symmetry that inverses have. Okay, so that's the part one of the test. Part two is, all it is, oops, yikes, is one linear regression problem. That's it. Okay, so get your calculator. Let's go through one of these, and then you can have the rest of the period to ask questions or work on the reviews or whatever you want to do. Okay, so to do this, remember all I want you to be able to do here, what I'm asking you to do is be able to generate a best fit line, the equation of a best fit line. So we're going to use linear regression to do that. We're just going to go stat, buttons I push turn red, right? Push stat, and then I can either push 1 or enter because 1's already highlighted. So stat, edit, and then this is where I put the stuff, right? So if I want to clear these out, if there's old data in there or something, I can go to the top and just hit clear, enter, highlight L1, clear, enter, and now I can just put the input and output values in. Remember, in this case, t is going to be the input and speed, v is going to be the output, right? Or velocity, v, okay? So put these in. There's my X list. Okay, once I get all those in there, all I've got to do, you tell me, how do I come up with the equation of the best fit line? 3 keystrokes, what are they? Stat Calc 4, that's it. Stat Calc 4. And then I just go down and hit calculate, and it generates the equation of the best fit line. That's it. So, of course, the calculator is going to always assume that we're using x's and y's. That's okay. We know in this case it's a little different. We use t's instead of x's and v's instead of y's. So when I fill in the blanks here, I've got v equals. I just need to take that equation, whoops, that one right there, and plug in ax plus b, but only the x becomes a t. So what's my a? I got to round this to two decimal places. So I get 3.37, but do I need to change the 7 or not? How do I know? I do, you're right. What's the next digit after 7? 9. So what does that mean?
It's above 5, so you're wrong.
Okay, I got to round up. If it's 5 or bigger, I have to round the 7 up. If it's 4 or less, I don't. Well, it is. It's 9, so that means that's got to be an 8. And instead of putting an x, if you miss this one, that's probably how you miss it. I'm going to put a t there instead because we're using t's. And then plus b. Well, b is positive, so I add it, and that's going to be 0.65. Do I have to round the 5 up?
No.
Nope. So that's my answer. Okay? So, did it? Yeah, give me credit. Okay, good. Okay. Have at it. You can work on stuff. Grab a Chromebook,